All right, Deborah, do you want to introduce yourself?
Hello. I'll apologise in advance. I've still got really bad hay fever. This year has been shocking. So apologise for snuffles and croaky throat. My name is Deborah Andrews. I am the academic lead for CEDaCI. My role at the university, I'm Professor of Design for Sustainability and Circularity, and have worked with the data centre industry for a number of years. And on various projects, and that's how I came up with the initial sort of concept for CEDaCI, and contacted lots of people. I think Naeem was the first, because we knew each other through international life cycle assessment conferences, and we built a team, and here we are 3.5 years down the road, which is really exciting. We've achieved a lot, and I'll explain when I introduce the project. And yeah, we're making really good progress. One of our key outputs obviously is the compass and training, offering advice, etc., to initially small to medium enterprises, but also large organizations, which is why we're really happy that you have come along to join us today. Okay, thank you.
Thanks, Deborah. Astrid?
Hello, my name is Astrid. I am from a company called TechBuyer. We're one of the project partners for CEDaCI. We are looking at Pilot B, which is product life extension. So looking at the business case for that, the financial incentives and the environmental incentives.
Nice, thank you. Chris?
Hi, I'm Christina Cowan. I'm research assistant for CEDaCI project. I've been closely working with Deborah Andrews and everyone at LSD.
Thank you. Kate?
I think Kate has troubles with
Sorry. Okay. No problem. Naeem.
Okay, so my name is Naeem, and I'm a founder and CEO of a company called Viloop. It's based in north of France, and we are giving support to the company's organization in terms of life cycle assessment and also social and economic and criticality assessment of different products, services, and materials. And I think now I have 15 years of experience in the field of life cycle assessment. And we are also involved in CEDaCI in the pilot on recycling. So together with partners in France like TND and others.
Okay, perfect. And as we are now still a small call, let's do a very also quick round of introduction for the wonderful audience that is here, so we can also better map which which life cycle stage are you part of, and then this will be easier also to ask questions and to maybe trigger some good discussion. So I will start with the order from my screen. So Dominika, you are up first.
Hello, can you hear me?
Yes, yeah, we can hear you.
Sorry, because I get some troubles just before with my audio.
Okay,
so
all good.
Dominique Martineau, so I am from Vitesco Technology in France, and I'm also responsible for a working group at the PFA, which is the automotive industry area. And so I think from the LCA, I'm quite familiar now with what is about LCA, and I was pushed by Patrick Blouet from ST for this training to understand what you are doing and how we can maybe reuse what you have done towards the power electronics for automotive. But I am quite familiar with LCA and all the stuff.
Very nice. Thank you. Thank you, Dominique. Dominika, if you're... Yeah.
Sorry, I thought you were asking me. I'm just working at LSBU as a research assistant. So I'm
What's your
part of the EU team, And yeah, I've been working closely with Chris on this assembly and helping out designing the actual interface of the compass.
Okay, very nice. Thank you. Frans?
Hi, I'm the founder of Quanza. We're a system integrator based in Amsterdam. We are a delegated operator for complex network infrastructures with a 24/7 network operations center based here in Amsterdam. We are members of the SDIA and we're currently involved in the project for a European sustainable cloud, which we are trying to build, and I'm hoping to learn a bit more about lifetime extension and also the reuse of rare earth minerals and stuff like that.
Great. Yes. Thank you so much. The next is Bram.
Hi, I'm Bram van der Ginten. I work at Ideal & Co Explore, a company in the Netherlands helping manufacturing companies in the design stage to achieve circular economy. So we're always in the design stage. And I'm listening here, as you do, I think, Julie, to carry over results from CEDaCI or ideas into the Replanet project.
That's correct. That's a new project that we are starting with some partners in the Amsterdam region, which we can share some information after. Yes, thank you. Nick?
Good morning, Nick van der Pas from Legrand, but subsidiary Minkels in Veghel, working in the Netherlands, and I'm quite active within standardization regarding efficiency of data centers, but also life cycle analysis and that part within data centers. That's my part. Yeah.
Great. Thanks for joining today. Igor.
Yes, good morning. My name is Igor and I'm working for Aliter Network. So we were part of the SDIA project as well. And now we are working for the new project of Replanet. So as well, like now the main results of this project to be able to use these results in another project. So yeah, kind of incorporate these two projects and get the best out of what we already know in SDIA project and put it maybe in a new project with Planet. So yeah, nice to meet you, everyone.
Thanks. Anilia.
Yes, hi everyone. So soon I'll be joining the Replanet project in TU Delft as a postdoctoral researcher. So I'm coming from computer science background, and I think this would be a really good introduction to the domain. So I decided to join today. Yeah.
Very nice. Thank you. So a lot of Replanet members in this call. That's good. Up we have Robert.
Hello, I'm Robert. I'm the founder of Ethernetics. We're members of the SDIA, and what we do is we're active in data centers, and we have a platform that is built on power distribution units in data centers in the racks, and it's built to on the one side be as carbon neutral as possible as a device, and on the other hand it runs software to detect activity or non-activity in the data center and helps data center managers to find that and to eliminate a waste of power.
Thanks for joining today this call. Glad to have you here. Up we have Bas.
Hello, good morning all. So Bas Jacobs, I'm actually working for the same company as Nick, so Legrand. So we do quite a bit of, let's say, manufacturing of infrastructure for data centers. And from that point of view, I work for as a product manager. So yeah, we can really influence the roadmap. So I'm really eager to learn a lot about eco-design and yeah, as a result, let's say, yeah, influence our roadmap and make sure that we contribute to building more, let's say, sustainable data centers. So glad to join.
You came to the right meeting.
Yeah.
Green data center and sustainable data center is what we do.
Yeah, exactly. Good.
Thank you. Lucy.
Hi, good morning, everyone. I'm Lucy. I work at Copper 8. It's a consultancy, small consultancy firm in Amsterdam we aim to accelerate the circular economy. And in that light, I'm currently advising a public organization on their data storage, but also their procurement of the hardware. So I'm here to learn some more about that and eager to learn about it. Thank you.
Great. Thank you so much. Leonieke.
Yeah, Leonieke Mevius. I'm the CSR Policy Advisor of SURF, which is a corporation, and the members are the universities and the colleges and the research centers. And I'm also responsible within SURF. I only focus on sustainable IT and try to work with as many other corporations as possible. So I'm a member of SDIA, but also involved in Replan IT a little bit and try to do Leap Circular in the Amsterdam region. So see what I can bring home from this. I use it again.
Thanks. Thank you, Leonieke. Next, we have Caroline. Caroline.
Caroline, yes.
Caroline.
Yes. Hi, or that I could not find the mail back, but we also joined the Replanet project as Rijkswaterstaat, of course. Or that, but the mail I was sent about this meeting reminds me of the Compass meeting I joined a few months ago. So I did not know exactly if I already saw something of the subject you're going to show. So I'll see. I'll just watch.
It's the plan is to show the compass, right?
Yes.
Deborah and Nadim.
Exactly.
Yeah.
Yes, but when I joined the meeting, the compass was not already online, so maybe that's different now.
Yeah. Okay. Thank you. Thanks for joining and making the time. Up we have Paul.
Hello, I'm Paul Trictonic. Do you hear me?
Yeah, perfect.
Okay, I'm working at IRT Saint-Exupéry. I'm a research engineer on the topic of batteries and fuel cell and life prediction. So we are interested on the ICV topics. So I'm here to learn about this. Thank you.
Great, thanks. Morjana?
Yes,
Sorry.
Marjana, hello.
Okay.
I'm working for the railway industry, but more particularly the SNCF company. And actually, I'm working for an innovation platform, which bring more industrials, more company working together to create solutions. Several solutions are about sensors on the railway. And I'm here to learn more about CEDaCI and maybe share to them.
Great, thanks for the introduction and for being here. And last but certainly not least, Manish.
Hello, good morning. I work for TESAM, a large ITAD organization, and I'm here to learn a little bit about what CEDaCI do and product life extension.
Perfect. Great. Okay, now let's kick off this meeting. Deborah, I guess you are up first. So Razi, if you can make Deborah presenter if there is a presentation.
Deborah, you are muted.
Okay, am I screen sharing now? Has that come through or not? You are. Okay. Okay. Okay, so I'm really pleased to see so many people here. It's really good. CEDaCI, yeah, we're just going to quickly go through an introduction, and at the end I'll give you a run through of what we're going to cover this morning. So in brief, and this is going to be a bit of a gallop because our introductory session was a little longer than normal, but that's good because we've got more participants. So yeah, a little quick introduction. We've got a session on life cycle sustainability assessment, which this is all the underpinning principles and research, which Naeem will do. Then we have an introduction to the data center campus. And then we're going to have breakout sessions with the eco-design evaluator, product life extension. So LSBU, we led pilot 1, which is design, so we're leading that session. Then product life extension is being led by TechBuy, who are experts in that area, and recycling and end of life are being led by WeLoop. So you can choose one session, and then we'll have a quick feedback and wrap up at the end. But I'll show you the timings in a minute. So as experts in the sector, I'm sure you're all aware that data centers and computing as we know it originated really from the Second World War, but the internet as is really took off at the end of the 1980s, early 1990s. And it's astonishing to think that 55% of the global population are now connected. And that's really important thinking about, you know, those figures, because it affects all the other things that have happened in relation to the data center industry. So around the world, the exact number of data centers, it's impossible to quantify exactly, but there are certainly over 7 million, and they range in size from, you know, an individual server in a cupboard to the hyperscale centers in, let's say, the edge of the Arctic Circle. There's a concentration of data centers in the UK, Germany, France, and Netherlands because of the financial sector. So this Interreg funded project sits perfectly in this geographical area. So the sector grew incredibly quickly. We've seen increased reliance on it, particularly during lockdown. There was a definite increase in data traffic. And we expect this to continue as there are developments in industry, and we are now moving towards cyber physical systems and the development of the Internet of Things, where just about every product will have some kind of embedded technology to feed back data and so forth. The speed and scale of the development within the sector mean that emphasis has been on service provision rather than thinking about what happens to products at end of life. So partly due to the nature of electronics anyway, the whole sector has grown up along a linear model of consumption where we take, make, use, and then dispose of things without thinking about second life, etc. And we really need to shift away from that model to adopt a more circular model. Now, in terms of circularity, I think the sort of rather naive understanding is that just means recycling at end of life, and that's not true. We believe that circularity is based on the waste management hierarchy, and that we should think about initially reducing resources and increasing resource efficiency through dematerialization, for example, that we increase reuse by extending product life, designing products that are repairable, upgradable, and so forth. When they are no longer fit for purpose, then we take them out of the system and we recycle and reclaim as many materials as is possible. And obviously all of these features are going to be discussed in more detail imminently. And then we anything that cannot be recycled is incinerated with energy recovery, and whatever's left over is disposed of. So those are the sort of things that really underpin the CEDaCI project, which we developed. We applied for funding in 2018 and received at the end of 2018, since when we've been using whole life thinking, bringing together representatives from all the different data center industry subsectors, which is actually quite unique. I think from talking to people who work in the sector, there was a general sort of feeling that something needed to happen vis-a-vis developing a circular economy or increasing resource efficiency, but nobody really knew how to do it. So the CEDaCI project has been a phenomenally successful catalyst in terms of bringing people together to share knowledge, because the only way we can really develop a circular economy is by sharing knowledge and taking a holistic approach. And ultimately, we are reducing waste, and this will have an impact on supply chains. We've seen evidence of disruption to supply chains through conflict, COVID, etc. So really need to shore those up to ensure that the data center industry can provide an uninterrupted and efficient service. So the project, we collaborate with partners in the UK, France, Germany, Netherlands, and we've received an extension to the project very recently. So we now also work with partners in Ireland, Belgium, and I forgot to put Luxembourg on there, apologies. We have co-creation workshops and working groups, so continually talking to and working with members of industry as well as research organizations. We were runners-up in the Data Center Dynamics Global Awards in 2019. We're going to apply this year, and we hope, I mean, it would be so fantastic to sit here and tell you that we've won an award, but we'll see how that goes. But we built a network that includes over 100 members now, which is really positive, and people talk to each other and learn from each other. So we identified 14 different subsectors across the industry. Again, you know, we're bringing everybody together, as many representatives as possible from the different subsectors. The one challenge that we haven't really been able to overcome yet is representatives from design and manufacture of not infrastructure, but products themselves, because so many are made in China, or in Asia, not just China, but places like Taiwan and so forth as well. And the products that are made in Europe tend to be, they're not manufactured as much as assembled. However, you know, we hope to overcome that. And we obviously concentrate a lot on design, because up to 80% of a product's environmental impact is determined in this phase. So what we are doing at the moment is the stage 2 and 3, or pilots B and C in the project, as with industry itself, are reactive, extending product life and recycling at end of life. We're trying to sort out problems that have been created because products have not been designed for circularity. The pilot A is very proactive, and we have designed a sort of prototype server that will be easy, or it fits the circularity criteria that I mentioned at the beginning. It'll be much easier to disassemble, upgrade, recycle at end of life, and so forth. So here are the pilots. A key output, you can see in the middle there, the CEDaCI, the Circular Data Center Compass. That's what we're really focusing on today. But we've also demonstrated that we can improve refurbishment, recycling and reclamation rates as well within the project. And we've developed some business models to support industry, and created eco-design guidelines for the circular economy. The big difference between the work that we have done for the LCA, the Life Cycle Assessment, Life Cycle Sustainability Assessment, an awful lot of other companies do things, but they are really relying on secondary source data and assumptions. And our data, we believe, is a lot more robust because we have collected primary source data by literally disassembling things or servers in the main, creating inventories. And then you can see the bottom images where the circuit boards, printed circuit boards and other electronic components are sent to our partners in France, TND, and they process them and extract and reclaim an array of critical raw materials that are not collected or reclaimed by other companies. That will become more apparent, or Naeem will give a more comprehensive explanation of that. So we really believe in what we're doing because, as you know, the data center industry is growing exponentially. By 2030, and these figures based on 2018 figures, growth has been ongoing, no major interruptions at all despite COVID, but we expect to see a 500% increase in provision by 2030. So we really do need to develop a circular economy. We can see that e-waste, it's the fastest growing waste stream in the world. At the moment, we deposit or create about 50 million tons of e-waste a year. And if we carry on doing what we're doing, i.e. not reclaiming materials, etc., by 2050, that is going to increase to 120 million tons a year, which is pretty shocking. At the moment, less than 20%, it's approximately 17% of e-waste is formally collected and recycled. It's difficult to say exactly where the remaining 80+% goes. Some is e-waste. It's not actually wasted because it's sold onto secondary markets, exported, maybe TVs, fridges, whatever are exported to lower income countries. But an awful lot of stuff is simply dumped and ends up in landfill or being informally collected and recycled in very hazardous and environmentally and health damaging conditions. So there's a real need to change this, particularly because when we see that there are typically 69 elements in electrical and electronic equipment, 7 to 10 of which are regarded as critical raw materials. In other words, the abundance is limited. What we haven't collected yet in the Earth's crust is limited. Recycling rates are very low, and the geopolitical location of the materials is very challenging. So it could be, for instance, tantalum, which is found in coltan, is collected in the Democratic Republic of Congo, which is an extremely unstable political location. So coming on to, again, a distinct difference between what we're doing in CEDaCI and what other assessors, carbon assessment does, excuse me. So if you are just assessing carbon and carbon equivalents, emphasis tends to be on operational and embodied energy rather than all the other materials, inputs and outputs that are critical to any product, but in our case, obviously servers. So if you look at the two sets, I don't think, oh yes, here we are. I hope you can see my mouse here. These two sets of results here, two different servers that were assessed, and we compared the operational impact here, the lighter green, with the embodied impact here. And you can see two different servers, but the ratio of operational to embodied impact, there's a very significant difference. Even in this case, operational impact accounts for 80% of overall life cycle impact and embodied impact only 20%. When we look at a full and comprehensive life cycle assessment, where we look at all the different materials, resources, it could be water, metals, plastics, whatever, all the different impacts that they create, we find that this ratio of embodied to operational impact shifts distinctly. And again, these are two different servers. They're the same servers here. With full LCA, we can see that embodied impact is much more significant contributor to overall life cycle impact. And in the case of this server, it accounts for about 50% of overall life cycle impact. So this really, really highlights why a circular economy is so important, because embodied impacts have really been through, because carbon is the sort of main metric, they're really underplayed. So yeah, I ran through what we're doing this morning. These are approximate timings. I'm not sure, I haven't got my watch on at the moment. It is 9:35, so slightly behind, but not to worry. Naeem is going to have run the introduction to life cycle assessment and sustainability assessment now for about 45 minutes. So we've got GMT here, or British Summer Time as, and then CET here. We'll have a break for about 5 minutes or so, and then come on to the introduction to the compass. And that's sort of applying life cycle sustainability assessment. And then we've got the final session in the morning. If you select one of the breakout sessions, which will run for approximately 45 or so minutes, and we'll have a final wrap up and feedback at the end. So the CEDaCI project, our funding, we're really lucky, it runs until summer 2023. There is a International Life Cycle Management Conference in September 2023, when we'll be presenting the final results. But if you're interested in that, please look or contact us. We can send you a URL. WeLoop are one of the organisers for that event, which is really significant. And then you can follow us on the usual social media formats and so forth. So if there are no questions, or I can see some points here. Julie has put slides will be available after the call. So more welcome. And then the project website Julie has put in the chat. And that's it. So thank you. I'll stop sharing and pass it over now to Naeem.
Okay. So good morning. Hello to everybody. So first of all, my apologies if I'm too fast in presenting you. I hope that you have fastened your seatbelt, because we will take this journey and it's quite fast. I need to transfer quite significant amount of information to you within around 45 minutes. So so I hope that we can discuss later in the question and answer. And yeah, so let me start with a short video. Please let me know if you can hear the sound.
Once upon a time, there was a lively underwater world in the Gulf of Mexico. All of a sudden, part of it, around half the size of Switzerland, was more or less dead. A stable ecosystem can reach a tipping point and become inhospitable to its inhabitants. But what does that mean for us humans? We humans have undergone unprecedented development over the last 10,000 years. Among other things, we have our stable climate, rich biodiversity, and intact nutrient cycle to thank for this. However, since industrialization, we have been interfering with these ecosystems through our consumer and economic activities. And this interference risks causing natural systems that have functioned for thousands of years to tip over. The crucial question is, when will we exceed the boundaries? The research community, led by Swedish scientist Johan Rockström and his American colleague Will Steffen, have provided one answer to this question with the concept of the planetary boundaries. The researchers collated all of the verified scientific data for years and identified 9 areas that are indispensable to the survival of humanity. These insights influence the definition of the UN's Sustainable Development Goals and are also considered directional by the European Environment Agency. Based on biophysical factors, there is a limit to the impacts that each of these 9 areas can tolerate. What is the maximum acceptable impact of chemicals and new materials? How big is the hole in the ozone layer? What is the limit on air pollution by particulate matter, the acidification of the oceans, the eutrophication of ecosystems, freshwater use, and the destruction of land and forests, how much biodiversity can we afford to lose? And how much climate warming can the Earth tolerate? If we exceed these critical boundaries, we run the risk of exposing our living conditions to uncontrollable changes. The current status? 4 out of the 9 boundaries have been exceeded. This means that we are exiting this safe operating space and putting our good living conditions at risk. Let us take the eutrophication in the Gulf of Mexico as an example. Fertilizers from agriculture and private lands reach the Mississippi, and from there they enter the sea. Due to the high nutrient levels, algae and bacteria proliferate and consume the oxygen in the water. Fish, crabs, and other marine inhabitants move away to avoid suffocation, and this, in turn, causes considerable economic damage for humans. But that's all happening far away from here, isn't it? No. The impacts of climate change, for example, are also becoming more and more noticeable in Switzerland. We're facing more frequent heat waves, longer periods of drought, and heavier storms. Native species and habitats are endangered. If we don't act now, we will leave many unresolved problems for our children and grandchildren. According to the researchers' insights, our generation still has a chance to counteract this development. And it is still possible, thanks to the concerted efforts of science, business, and the authorities. We were able to shrink the hole in the ozone layer considerably. So, instead of risking the very foundations of life, we should adapt our technologies and behavior so that they are compatible with the boundaries of our planet. This is no easy task and requires completely new thinking and action. For example, in the area of finance, we need finance and investment decisions that take the planetary boundaries into account. How? By no longer investing in fossil fuels, but in projects with a positive impact on the environment. For example, in the economy, we need companies that minimize the environmental impacts in their value-added chains, and in this way also reduce their business risks. And we need companies that base their business models on the planetary boundaries. For example, in politics, we need political actors that create goals and conditions for society and the economy, which will lead us back into the safe operating space. For example, in society, we consumers should ask ourselves what and how much we really need, and what really makes us happy. Finally, we must see our situation as an opportunity for market-altering innovations. We only have one Earth, and its resources and capacities are limited. What is unlimited, however, is our creativity and capacity for innovation. Let's use them.
Okay, I think this is a good introduction for my presentation. Now let me move to slides. Okay. So I believe it was quite explicit, the situation, and I think you have heard a lot about the necessity of having an approach that is in line with the sustainability goals. So that I will skip. But what we are doing here is an approach based on what we call it life cycle thinking. So we are using a multi-stage, multi-criteria life cycle approach, and we consider all the life cycle stages from the raw material extraction to the manufacturing, distribution, use, end of life. And we quantify economic, environmental, social, and criticality aspects related to the product to give a possibility to a better decision making based on life cycle thinking. So we in the CEDaCI project, we are developing, or we have developed 4 indicators that we use in presenting the results. So those indicators are, first of all, environmental indicators, criticality indicators, cost indicators, and social indicators. For environmental aspects, we base ourselves on the recommended approach by European Commission that I will present to you briefly in coming slides. For criticality, we are using a method to analyze the criticality assessment. And for the cost, we use life cycle costing to look at the costs that appear all along the life cycle. And for the social aspects, we base ourselves on the guidance from United Nations to develop social LCA, social life cycle assessment. So let's see what are these different indicators, and let's start with the environment. So first of all, we need to know that we are not only concerned by the climate change, but we have also other impacts. Here I provide a list that is not exhaustive. So climate change, resource depletion, human toxicity, abiotic resource depletion, fossil resource depletion, eutrophication, acidification, ozone layer depletion, ionization radiation, particulate matters, land use, and land use change. Whenever you are facing or you are looking at a new indicator, I recommend that you ask 5 typical questions. What is the definition? What are the negative effects? What are the human activities responsible for these undesirable effects? Substances, element causing these effects, and physical and chemical causes. If you ask or look at these 5 questions, you are able to assess and understand what is behind different impacts on environment. Is there any of these indicators you want me to briefly present? Maybe you can note or write in a chat. I will come back to the indicators. So Julie, if there is any questions, please note them. In 2 or 3 slides, I have opportunity to come back to these indicators, but time is too short. So what do we use for the environmental assessment? We use life cycle assessment. What is life cycle assessment? Is a method that looks at product, service, organization life cycle, collecting inputs and outputs, materials, energy, and outputs, emissions to water, air, and soil, and then transforming these inputs and outputs into impacts. Climate change is one of them, but not only, and we have other indicators or resource, etc., etc. There is one very important point in what we do, and this is defined in our goal and scope. It's the functional unit. We are going to compare, or at least try to compare, some products in order to be able to make a better comparison, because we cannot make a perfect comparison. We need to define what we call it a functional unit. So functional unit is a measurable unit that is identical between different scenarios and allow us to compare products that are not per nature comparable. For example, in place of comparing plastic with glass, we compare the function of drinking water. So we specify a quantity of water, and then we can compare different solutions. So that's what we do in the CEDaCI, and that's very important. I give you a few examples so you understand what is functional unit and what is reference flow, and we try to discuss afterward what would be a functional unit for a server or data center equipment. So as an example, if I take shoes, so if I want to define a functional unit, we need to walk in proper conditions for a specific time period. So here, for example, it's for 1 year, but you can define it also for a specific distance. What is the reference flow? What do I need to respond to that function? For example, if I take a low quality shoe, I probably need more, so 2 pairs of shoes. But if I have a high quality shoe, then I need less than 1 pair. So if I want to compare these 2 products and the function of walking in proper condition during a year, the amount of product that I need in the 2 situations are different. If I look at the function of hand drying, so it's to dry a pair of hands, and then you can have very different reference flows. So I can either dry hands with paper towels, or I can use a hand dryer machine. Then I need to know what amount of time, and what is the power to be used to dry hands. So let's ask now the questions with regard to the server. So when we want to define a functional unit, and this is quite important, that's why I will probably spend few seconds more. Most of the times a few minutes, but here we don't have minutes, so a few seconds in addition. First of all, you need to answer to the question, what is the function? So what is the main and what are the secondary functions? Then the extent of the function or service. So what is the measurable unit that I will base my comparison? For example, in the case of drying hand, it was this 1 pair of hand. Then the expected level of quality, for example, for the shoes was to walk in a proper condition, and then the lifespan. So how long, for how many years, or for how many distance, or whatever. So can you tell me what would be your functional unit for a data center equipment? Let's take a server. And if someone want to react, I think the best is that you open your mic and you try to give an
compute
answer.
Power.
Okay, so that's the function.
Mm-hmm.
What about the other questions? What is the quality? What is the extent of the function? What is the duration, lifespan?
those are less easy to answer.
Yeah. That's exactly what I want to get to. So it's good because you are getting to the point quite fast. Makes my life easier. So I can tell you, I will show you a definition for functional unit of server. I think I have presented this definition 50 to 100 times. And each time it's very complex for me to defend the position because we do not have a perfect functional unit. We have a functional unit. We try to base our comparison, but yes. So what we did for CEDaCI and what we will show you from now on in terms of results are based on this functional unit. So we are focusing on storage and computing, which are probably the most important functions of DC equipment. We are looking at one server that answers to specific minimum requirements. So I had a lot of discussion on the one server because some people say, no, we should consider a specific storage capacity, 1 terabyte or 10 terabyte. But then the problem is that you might have a server that has a big capacity of storage and you never use that storage capacity. So it's really complex to define a better extent of the function, which is the most important characteristics actually. You need to know that what we will propose you in this project is not perfect. That's why when you look at the tool, we give you the possibility to configure your server according to your needs. So when you make a comparison between two servers, we believe that your expertise or you have the expertise to be able to make those two settings and make them comparable. Okay, so we try to reduce our responsibilities slightly in that sense, giving you the possibilities to adjust the servers. Then definitively, depending on the purpose of use of the server, you might have different parameters that need to be considered. We also offer you the possibility to change the use phase energy. So depending on your location, etc., in the tool, you have the capacity to change. And you have also the capacity to change the intensity of electricity use in the tool. For instance, if you have a server that you use always at the maximum rate of use, it's not the same as you have a one that is half of the time on standby. So it depends, and we give you the possibility to adjust. For the lifespan, we had a lot of discussion. The main lifespan is based on 4 years with the possibility of extension of lifespan of 3 to 4 years in the case of reuse. So 4 years as a first life and then 3 to 4 years of extension. Is there any questions on the functional unit? I prefer to stop here if there is any question and then, okay, perfect.
Well, just one name, sorry. These are quite arbitrary numbers, right? I mean, 4 years of initial lifespan. For example, the Dutch tax authorities only allow companies to depreciate equipment in 5 years. Clearly, if you have a good reason, you can always do it quicker. But 4 seems short. We see more 5 to 6 years, and we see customers extending for 4 years after that. I mean, sort of depends on the workload. It's something that is not set in stone.
Yes, it's a very relevant question, and unfortunately, I cannot answer clearly to that question. What I can tell you is that according to different average usage intensity data we could collect, we believe that 4 years can be a good assumption, knowing that most of the time today there is an extension. So this extension can be 1, 2, up to 4 years. That's why we believe that with 4 years plus 4 years, we are able to cover a good representativeness of the market. We couldn't find a server that was going really beyond 8 years overall of lifespan. So and if it goes beyond, it really needs a major change in the equipment and parts. So I agree with you. Okay, so depending on your use or applications, these 4 years might be 5, sometimes 3, sometimes 6. But with the two complementary concepts, first life and second life, I think we are good, more or less. Huh? but it's not perfect. Huh? I agree with you, and this is debatable. Like you can also debate on the question of one server. Why one server? Why not a specific capacity? Why not a specific capacity of calculation? You know, these are all questions that are completely relevant for which we can just give you a partial answer. Yep.
Sure.
Naim, Manish has had his hands. Do you have a question, Manish?
Yes. Question for Naim. Based on what you've just said, the extension of 4 years on the server, on this particular server, on this in question, how many components are changed to extend the life for 4 years within this particular server?
So that's a very good question. I believe if you are really interested about that topic, it's good that you participate in the reuse refurbishment group that will present in detail, because my knowledge is limited. I don't remember all the numbers. But
roughly,
I think
sorry, Naim, is it less than 10 or over 100?
Oh, is there anybody from the group can present? Yeah, please.
Yeah, sorry. You can just keep running it generally. Maybe you'll need to replace a hard disk after a certain amount of time. It starts to show certain failures, but it really should just continue to work.
Yeah.
It will just not be state of the art anymore. It won't live up to the speeds that new machines are providing. So that's mostly what you would be seeing.
And the practice is quite different. So we have seen some different practices in the project. For example, the fans are systematically changed because those are very sensitive elements. So in the operation of reuse refurbishment that we have seen, for example, the fans are changed. Hard drives might be changed or not, depending if the capacity is still acceptable, the speed is good enough. So these are all the parameters that also play a role. But at least I have seen that the fans are changed. I think our colleagues who work on this work package, they provide us a good and detailed data to be able to model, and I think they can give more insight. But I believe, yes, let's say 10 to 20% of the components are changed.
Thank you.
You can also decide to add more components because the server has the capacity. Sometimes it's not used of its 100%.
That's what I was getting. That's what I was going to go on to, but I'll wait for the next session.
Yes.
Thank you, Naim.
But if it's for you adding other elements, you will see that in the tool, we give you also the possibility. For example, if you want to add more storage capacity to your server, you are able to change. Okay, so we don't fix it. We give you the flexibility. If you want to add RAMs or CPUs, you can also do that in the tool. Let me also keep some of the tool aspects for the tool part. Okay, so let me go with lifecycle assessment. We use lifecycle assessment to do the environmental assessment. It's based on 4 steps. We define goal and scope. We create an inventory. We do impact assessment, and we do interpretation. Here I will just briefly present you the impact assessment because it gives you the possibility to understand the results that we will show you. So for the impact assessment part, we are using both mandatory and optional phases, which is classification, characterization, normalization, and weighting. So for the first part, this mandatory part, first we do a classification. What does it mean? So you have all the elementary flows, so all the exchanges with environment that are classified under different impacts. For example, if I have CO2, if I have methane emissions, those goes under climate change, global warming. If I have use of aluminium, copper, and other metals, it goes under resource depletion element. So I classify, this is the classification. Then I multiply them, but what we call it a characterization factor, or in some cases you call it emission factor. For example, I took a very easy example for the greenhouse global warming. If you have 1 kilogram of CO2, 1 kilogram of methane, and 1 kilogram of N2O, then you can multiply them by their characterization factors. For example, according to the version of IPCC that we use, 1 kilogram of methane has 36 times more impact. If I take the same impact for resource, I also make an equivalent according to one of the resources. In case of LCA, we use antimony equivalent. If I make energetic resources, I make it based on megajoule equivalent. Okay. What do we use as method? We use the European recommended method. It's called EF 3.0. It's a grouping of existing European methods, but the best practices. It gives us what you can see on the screen. We have 16 indicators starting from climate change up to resource, with different methods behind scientific development. Some of them are really recent. For example, if I take the particulate emissions, this is a new development from United Nations Environmental Program back in 2016. If I take water use, this is a new developed method, which is the first regionalized method that is implemented, which is called AVER, that considers stress for water depending on in which region you are using the water. So water use in Europe has not the same, it's not having the same impact as if I use the water in India or in China. Each country has its own stress level of water and other indicators. So Julie, was there any questions regarding the indicators? So I can probably give some answer now.
There is no question in the chat, so if anyone has one, you can raise your hand. Otherwise, yeah, you can continue.
Let me give you maybe few very fast inputs. For example, here you have ionization radiation. This is today the only indicator that looks at nuclear energy sources, because we have radiations and this counts the radiation and the impact that we have on human health. And you have others. These are the two resource indicators, one on minerals and metals and the other one on fossil. So also again, the nuclear, for example, the uranium is quantified in the fossil, in the energy-based resources. But all the metals, minerals, for example, tantalum, copper, etc., are assessed under the resource use indicator, etc. So if there is no other, we have also some human tox indicators. So some of the metals has quite some toxic indicators and other indicators, as you can see here.
Just one question, Naeem. Yes. The column robustness, what does it indicate? What does it mean?
European Commission did an assessment, because when you want to put objective of reduction in a company, you need to know if there are uncertainties related to these indicators. So they did this robustness assessment. So you need to consider some of these indicators with more care. And also it's a way for Commission to improve them. So some of these indicators will be revised in the coming years to find good substitute for them. Yeah.
Okay, thanks.
Okay, so now the question is, I put 16 indicators in front of you. You have 3 different servers. Is it possible to make a decision? Now I made your life simple, okay? I took 13 indicators out. I just keep 3 indicators: global warming, so greenhouse gases; ADP, so for resource, abiotic depletion potential in antimony equivalent; and water use in meter cube. We have product 1, product 2, product 3. Imagine that there are 3 servers. So numbers are fake. Yeah? It's just to make exercise together. From your point of view, which product are you going to choose? If someone can tell me which one, then I give a big prize to that person. I know that there is no answer. If not, I was not defining any price. So actually, it's too complex. If you look, so for global warming potential, the product 2 is positioned in middle, but it has the biggest resource depletion, 0.44 kilogram of antimony equivalent. How on earth I can compare these 2 indicators? So if I go to the water, then for water depletion, the product that is best placed for CO2 is consuming 4.9 or impacting 4.9 meter cube water. So, and this is simplified because I just put 3 indicators, not 16. So we need more steps to be able to simplify. Okay, we lose some of these knowledge and scientific base, but we get to something that is easier to be used for decision making. So that's why we use the normalization and weighting process. Normalization is to bring numbers to a comparable unit. In the case of European approach, we use per person. Okay, and recently it has been updated. We are using the global population to calculate and the global economy, and gives us the impact per person. So 1 person, what is his impact for climate change, for resource, for water, and we can divide to get our impact per capita. Then we weight them. Why? Because it's not enough to just normalize. We need also to give the importance of different impact. So this exercise, what was done at European level with what we call it a panel-based method. So it means European Commission collected information from experts and society with regard to the importance of these indicators. So they give them some information like a short training, and then they ask them to qualify what impact is more relevant. And for the expert is done in a different way. And this is the result. So for example, climate change represents alone 21%. So the summation of these numbers is equal to 100. So climate change, 21%. Both resource indicators are representing around 15%. So resource mineral 7% and resource fossil 8%. So when I obtain the results, I weight them. So I reduce the effect of resource compared to the climate change. Climate change will be 3 times more amplified than the resource to make my weighting. Okay, and this is the coefficients that I use. Just to make a summary, what I do is that I take the environmental impacts. Here I just put 4 gas and particulates. Then I classify them under impacts. Then I characterize them according to their characterization factor. And then I normalize by dividing by person. And then I weight them according to their weighting factor, which are provided here. To obtain what we will call, if you use the European method with all these indicators, we call it single score. So the results I will show you will be single score. It will be a aggregation of all these impact categories and weighted according to the weighting sets that are defined by European Commission. Do you have any questions up to here? Sorry, this is significant amount of information I'm giving to you in a short time, so might be complex. Then the next one, next indicator is the criticality indicators. Okay. In the second part of my presentation, I will show you some results, concrete results with regard to the CEDaCI. For the criticality, you have several available methods. So before I go to the definition of the method, I think you know that the resources are quite important. We are using more sophisticated product that covers much more metals and elements. And this is also crucial for the technology and high-tech products and evolution in emerging technologies and innovations. Resources are source of problems. It generates burdens on environment. We have a big problem of dependence, and we might end with some international crisis. And we have also social issues more and more rising in local populations where these resources are extracted. So it's a big issue and it needs to be tackled. That's why we have added these indicators. So first of all, you need to define what is a critical resource. Two elements are essential to define a critical resource based on European definition. If we are vulnerable to supply disruptions and if it has a high economic importance. Okay. So if I have a high risk of supply, and if the economy is dependent and for which I cannot find an adequate substitute, that resource is considered as critical. According to the Commission, we have today 20 critical resources that I highlight here. So for example, cobalt, recently lithium and other resources are classified rare earth elements. These are resources that are classified according to European Commission as being critical for Europe and European economy. So we use a method to do this criticality assessment that takes into account, for sure, geological availability, then geopolitical accessibility of resources, recyclability, and then according to the content of metal, we can develop an absolute number for short-term and long-term in terms of impact. To do so, we first look at the supply of resources. We qualify the countries in which these resources are supplied in terms of stability, geopolitical stability. For example, we use a world governance indicator to assess the geopolitical stability of the countries under 6 different criteria like political stability and absence of violence. And here I put, for example, the control of corruption. But we use the 6 indicators to make a geopolitical indicator, and then we have the rate of extraction and purification of these resources in different countries. So we are able to attribute a sort of criticality in terms of stability in geopolitical aspects to the resources. And then we also look at the amount of resources that are used to build our indicator. I will show you some results later. which is quite sophisticated indicator at the end of the day. The next indicator is the social indicators. As I said, we use UN guidelines to do social LCA. For that, we have this method that in place of looking at different life cycle stages, material stages, we look at different stakeholders. So it's still based on product vision, but looking at the stakeholders. We do this approach based on 4 steps: defining the goal and scope, collect data and data collection in terms of what is the relevant indicators. And then we do interviews, surveys, which was a quite time-consuming process in this project. And then we interpret the results. You have a big set of indicators defined by UN in terms of social aspects, grouped under 6 different categories: employee, workers, local community, value chain actors, consumers, society, and children. The first step for the project was to identify what are the indicators that are relevant for data center industry. We did a sort of stakeholder data collection among our network, and we identified the most relevant. For example, you have the different indicators that are relevant here. For example, the children category was excluded, except the education provided to local community, that we moved to the local community indicator. And you have the set of indicators that are remaining. For example, if I take an example of local community, we have access to material and immaterial resources, delocalization and migration, respect of indigenous rights, and local employment. If I look at the consumer aspect, it's consumer privacy, transparency, and end of life responsibility. And you have all the other indicators that are reflected and selected. The last indicator is the cost indicators. For the cost indicators, we take into account the lifecycle costing. The lifecycle costing covers all the costs appearing through the lifecycle of the product. For the purpose of lifecycle costing, we collected a significant amount of, first we defined what are the elements that generate cost over the lifecycle, and then according to the expertise of the partner in the CEDaCI team, we collected the data and we did a lifecycle costing for the product. For example, if I take the example of recycling, we collect the cost of recycling, but also the revenues related to the recovery of different elements. So do you have any questions with regard to the indicators before I move to the presentation of some results? Again, apologies.
Yeah,
it's
there
too
are some
fast.
questions from
Yeah.
Paul Naim. So first question was, do the coefficients move regularly and significantly?
Sorry,
That was,
can you answer?
do the coefficients move regularly and significantly? I think it was related to the, or maybe if Paul, you want to explain further your question.
Yes, is it related to the impact as indicators that are used to assess the impact, or it's related to the final results?
Yes, to have a big indicator to aggregate all the impact. These coefficients are stable or maybe move regularly?
It's a very good question. So for the environmental part, for the moment, Commission fixed the indicators, but I believe in the coming years, there will be an update. So let's say within 2, 3, 4 years, we will have an update. It's already 2 years that we are using. So maybe in 2 years or 3 years, we will have an update. For the criticality, it's very, very significantly changing. So for example, the indicators I show you in terms of geopolitical aspects are updated by World Bank each year. For example, Russia here probably is not that unstable, but I think next year it will be completely red, or Ukraine. So these are things that are changing a lot. So it requires some updates, but we can say, okay, here we can also consider several years before updating, because so we need to update anyhow. Cost indicators are more or less stable. The problem is that now we have some also inflation that will change. Social is probably the one that we can consider for a couple of years before we are able to change. So we need to wait for more long time to be able to change and improve social indicators. I hope that this is giving you an answer.
Yes, thank you. And the other question is about the source of the indicator? Do you see some difference if they come from Europe or America, Asia or Africa? Do you have see some sensibilities to the source?
Yes, absolutely. If you are doing the same exercise in China, you absolutely don't get the same impact, because you will, for example, for criticality, you will look at accessibility of resources for China. This exercise is done for Europe. So criticality definitively changed completely. It's absolutely not usable in another continent, except if the continent has similar economic situation compared to Europe. Cost is usable in different continents. Social, it depends on the local regulation. So if you go to one country, maybe some of the social values in Europe will not be the same. So that can be also slightly different, but I can say that it's more or less usable. On environmental part, normalization and weighting is developed for Europe at this moment. This normalization and weighting is not for other continents. In other continents, you probably need to use another method. But for me, the environmental impacts are more or less also stable. So you can use it also in another continent if needed, or another country.
Okay, thank you.
Other questions? I'm happy with these questions because they are two. It shows that there is an interest. They are really technical and specific. We have a nice group today, yeah? That's quite good.
Yeah, no further question on the chat.
Perfect. So let me now show you some results, because okay, that was impressive, the amount of information data we need, but what about results? How do we see the results? How difficult is to interpret those results? So let's start with the environmental aspect. So we take into consideration everything. So we did a very big modeling for life cycle assessment. We did a modeling that is parameterized, so we are able to generate results for other servers. This take us a lot of time, so we even go beyond the time that we initially thought that we need, because the model is really complex, sophisticated, and we wanted to make it really updatable, reusable, and optimized. So you have, if you go dig into the model, you have all the life cycle stages, from the raw material manufacturing, use of components, recycling, etc., etc. So we are using everything, and we are complying with the European requirements in terms of modeling. So before I go to the results, I probably ask you two questions. If you want to look at a server, if I take the RAMs and hard drives out, what is the component for you that has the biggest impact? That's my first question. So inside the server, you have motherboard, you have PCBs, you have the electricity supply system, etc., etc. What is for you the component that has the biggest impact? And the second one, I think somehow Deborah already mentioned, but what would be the share impact of use phase compared to the components? And I think we don't have time. So I just wanted you to think about these kind of questions. These are regular questions that we think about. So here I show you a couple of results. So this is a server. I think this is maybe one of the oldest servers that we assessed, maybe from 2010 or 2012. You see that we have some impacts related to the chassis, screw, and other elements. We have a very big impact on the motherboard PCB. This is the biggest hotspot in a server. Then you have other PCBs that are representing also big impact. Also the PSU, because it has a lot of, for example, copper or other elements. And then depending if you add hard drives, you might get impact also for hard drives. So I didn't add it here because I wanted to keep a server without any hard drive and RAM. And also if you use different components, you can have additional impact to this. This is the impact of use phase. We calculated this impact in what I will show you. We calculated based on an average energy consumption between Netherlands, France, UK, and Germany. We attributed 25% of energy mix to each of these countries. So you can change this energy mix in your assessment and you will get your specific impact. For example, if you are in France, I believe if you change the consumption to France, your CO2 emissions will be reduced because you are 80% nuclear, but the impact of, for example, ionization radiation or the impact of resource use fossil, which is related to the use of uranium, will be higher. So these are kind of information that you can adjust in your modeling. Here I show you on 2 different servers the impacts. So these are 2 servers from different generations. Here you see the results are showed in single score, the same for the previous one. So this single score is calculated according to what we discussed. So taking into account all the 16 indicators, normalized and weighted. Here you can see the impact. So I tried here to show you some impact, but we will see also this kind of results in the tool. This is the use phase. So if you take your server, okay, here I mentioned landfill, but it doesn't mean that the server is going to be 100% landfill. It's going to be used in a conventional end of life scenario. You see that the impact in this case is even bigger than the use, okay? And we are not having a very high impact energy in use because we are mixing France, Germany, UK, and Netherlands. If you go specifically to a country in which the mix is, the energy mix is higher in impact, this use phase can be adjusted, or if you go to a smaller, then it can go lower. But you can see that it's quite comparable. Even the impact of equipments are bigger. And if I go with the recycling scenario, so I try to recycle a part of the equipment, so as much as I can, improve my recycling. This is according to the recycling that we will show you in the breakup sessions. I can get to similar level or slightly lower. And this is another server. You can see in the new servers we have, okay, I don't say it's always the case, but in most of the cases we have a reduction of impact. Because you can see here that impact of a recycled old server, it's around 50 points. Here we get around 30 points on the similar server. So we have also an improvement more or less on the servers, but it's not always the case. So I cannot say systematically that we have an improvement. It depends on the technologies, on the brand, etc., etc. So here, for example, it's comparison between the 2 servers, looking at the material and components impact. So here we can compare different type of scenarios. You will see that in the tool you are able to compare recycling with a high rate of recycling, with conventional recycling, with landfill, or with reuse, refurbishment. So we give you the possibility to do this kind of comparison and look at environmental impacts. Okay, one point that I forget to tell you, there are a lot of discussions to say that impact of global warming is important. But here you can see the relative impact of resources compared to the global warming. We believe, we can see that in the results, the resource impact for the servers is the most important impact. This is because we consume a lot of resources. And even if I look at the energy, we are consuming a lot of. Could you say that again? Sorry, this is my Apple Watch. So you can see that the resource indicator overall in the server is really significant in terms of impact. And for me, it's quite misleading just to focus on the climate change. If we believe that climate change is important, this is the total impact of server. You see that if I consider the use phase with a high rate of greenhouse emissions, this greenhouse, it becomes similar to resource and similar to the fossil resources. So I need to consider these indicators together, not focusing a lot on one and forgetting the others, which is probably sometimes the case. Then let me show you a couple of results for the criticality. So as I said, the criticality indicators are covering the geological aspects, the geopolitical aspects, the recyclability aspects, etc. And we have the opportunity to characterize the equipment so we know exactly what is inside them. Because when we started the project, we tried to collect and the data was not available. So we did a reverse engineering, as it was presented by Deborah, to collect all the data ourselves. And that was used to do this criticality assessment. So let me ask you a question. Do you believe that an SSD, so solid state drive, has bigger impact or smaller impact compared to hard drive in terms of criticality, not environmental? Here I'm comparing criticality. Anybody has an idea which of these are higher in impact? And can you tell me which metal for you is big impact in these 2 equipments? Let me go to the results. We don't have a lot of time. So here I show you 3 different drives. Okay, so okay, first of all, you will see that the capacity of these drives are really different, but no worries, because we have tested also the recent hard drives with higher capacity. They still have the same tendency in terms of resource consumption. So it doesn't change dramatically what I will show you, maybe slightly, but not that much. So you see that we have these 3 different technologies, and we compare the criticality aspect. So you see that blue and orange are the hard drives. So 2 different technology. You see that we have, for example, because we have magnets, we have a big impact related to the rare earth elements like dysprosium and neodymium. But if you go, for example, to SST, then it's other type of impacts. For example, we have impact on strontium, tin, antimony, and gold. So these are things that we were not expecting that much, which becomes higher in case of SST. So we cannot say they are similar, but they are different in terms of impact. And this is the short-term criticality. If I look at the long-term criticality, you see, for example, that I have a very big impact in terms of consumption of tin in the SST or antimony, or again, other metals. Let me show you also a couple of results on social, knowing that social is probably the most complex to present, because we are in a state of maturity that is not the same as environment and criticality. Here, the methodology itself is at R&D phase. So I think it's the first work that is done at this scale. It was a crazy amount of the work, interviews. So all the CEDaCI members and partners contribute to this data collection. We run several interviews. So here I show you a few examples of interviews. You can see that I show you the results on the impacts that I already show you. So for example, here you have employee, okay, employee. So like, I don't know, fair salary, working hours, child labor, sexual harassment, or other stuff that are presented here. And then you have the local community impact, you have society, you have etc., etc. So you see that we can monitor the social impacts. And here we are comparing the mining sector from high risk metals, it's in orange, and the conventional metals. So here is the mining of metals. Here is the recycling. So for high risk illegal recycling, it's in orange, and blue is the conventional or more controlled recycling, and you can see the social. So bigger the score, higher the positive social impact. You see that for environment and criticality, higher the impact, it was more negative. So we had a problem here. We need to transform this positive social into negative. So we did a sort of additional calculation to change them into negative. But still, I continue. Here we have also done interviews with regard to the remanufacturing, refurbishment, and also interviews with regard to the use of server. Now we have even more because we have done more interviews. So we did.
Naim,
yes.
There are some questions about the short-term and long-term criticality. Could you please perhaps
So
extend?
Julie, yes, maybe let's go to the end. I will also present the cost, and if you can collect all the questions, I try to answer at the end, because I think I'm slightly short in time. So at least then I'm sure that I presented you the essential things. So here, for example, if you go to the level 4, it's a committed situation. You can see that even when we do remanufacturing, there are points that we can improve the social impact. Okay, so we can learn a lot from social LCA, and I always recommend to those who are using to go deep into the results to see what is the hotspot in terms of social. Here is what we did. So we transformed the results into negative. We also built scenarios. So for example, when I'm looking at landfill server, so it's not 100% landfill now, it's going partly landfill. According to a conventional scenario, you can see that we have different impacts. So this landfill scenario is the highest impact. The business as usual recycling is here. If I go with the reuse refurbishment, then this is the social. So lower the social impact here, better it is. We transform the negative into positive, and you can see indicators per indicator, the impact. And the last indicator is the cost. So for the cost indicator, we have different components, we have different scenarios. And as I said, partners go and collect data. For example, if I take refurbishment scenario, we consider what components are changed. We consider the cost of those components and then the revenues from refurbished server. And we try then to make an assessment of cost. For example, for recycling, here are the examples of the collection for recycling. We have collected the data on the equipments that are needed. We transform them per ton, and then also the metals that are recovered according to their percentages, and we calculated the revenues of different metals. So it gives you also the possibility to economically compare the different options. So these are examples of the data that is collected. So I think now I can spend some time on the questions, Julie, if you can. Yeah. Your mic is cut, Julie.
What about now?
Yeah, it's good. Thank you.
Yeah, okay. There are some questions about the short-term and long-term criticality in the chat by Elisa in France.
Okay.
So could you please?
Yes. So the short term, and it's a very good question, the short and long term. The short term indicator consider the geopolitical stability of the countries. Long term do not consider geopolitical stability. Why? Because at short term, if a country is not stable geopolitically, you will have a supply risk problem. But when we look at long term, we know that countries become stable and stable through the time. A country that was stable 6 months ago, now it's completely unstable. That's why we say for long term, we don't consider stability. We look at the availability of resource, recyclability of the resource, and indicators that are not linked to the geopolitical aspects. So that's the difference. So if I go to short term, we know that, for example, dysprosium and neodymium, these are resources that are controlled mainly by China, supplied around 90% by China. But the rare earths are not that critical at global level. That's why when I go to the long term, the impact of these same metals are still high, but it becomes relatively lower. While, for example, impact of tin or antimony, which are the resources that we don't have available significantly in Earth's crust, become more important. This is the definition of the short and long term and the way that we consider them, this calculation.
Great, thank you. And there are two more questions. So France is also asking, do you have a recommendation on whether to choose SSD or legacy HDD if I invest in a new server today?
Okay, so do not consider this as an official answer because it's two-way, but I think if you want to go with sustainability, I think SSD is better. Why? Because for HDDs, we are not today able to recycle the rare earths, so most of the rare earths and metals inside are lost. The impact of producing that is quite high. We have dismantled quite a lot of HDD, and it's a very, very big pain to dismantle them. It's almost impossible to take the magnets out. You have to break everything, and probably you get some injured people during the dismantling process. So personally, I think the SSD, if you consider how they are produced and how they are supplied, because we did a test on one or two, but you probably need to look at the brand, look at the specifications, and if you want to buy a lot, I even recommend to do some additional tests specifically for your choice. I think SSD is better.
Thank you.
Not official, huh? Julie, your mic is cut again. Sorry. Yeah, now it's good.
Now, yeah. Okay. There is another question from Nick. Interesting question. So, what about the impact of upcycling?
Okay, if you recycle in a better way, yes. What is meant by upcycling? Yes. Or can you give me can you tell me what is meant by upcycling here?
And I mean, you're looking here at that the life cycle is already defined that in a certain way. but
Okay.
I think we can influence what we do with certain components. For instance, can imagine casing of servers can be reused, things like that. What if you have reuse, recycle? How does that impact?
Yes. So what we can say is that when we started the project, we have a doubt because we have a discussion on the energy consumption, etc. And I think now it's quite clear for us that whatever you can reuse, recycle, it's good. It's very positive. So everything that can push you to even upcycle, if you want to recycle with high quality, it's very welcome. Can you reduce significantly your impact? At the same time, I think there is one big issue is that most of the time our feeling is that the servers are over configured for the users. I think there is a problem between the real need and what we give to the user, and we can work on that specific point. So then the reuse and recycling of servers or part of the server become more and more relevant. Okay, so this is maybe an important point, but in any case, social aspects, environmental impacts, criticality issues, and even cost, it's better to go with the reuse and recycling.
Okay, Deborah, you had your.
Yeah, I was just going to say that actually upcycling, it's sort of inherent in our compare model in the tool, because you can upgrade component swap in and out components and see how that changes environmental, social, and economic impact, and obviously criticality as well. So it's sort of inherent to the compare tool, although we haven't called it upcycling.
Yeah, I think what we will present you in coming minutes in terms of tool, it's really complementary to what I presented to you. It will show you how we can use. Here I show you just sample of results. There you have your freedom to do the way that you like on the server. Yeah.
And there is a last question from Baz. What is the scope for CEDaCI products / materials wise, IT equipment and IT infra and building, or a subset of these?
Okay, so the scope initially was only to focus on equipments. So we wanted only to look at the equipments, but we find it out that if we don't put the energy consumption aside, it's probably something missing. So that's why we added the energy consumption. Then we tried also to give you this possibility to add several equipments, but know that the building is not considered in the scope even now. So you don't have any possibility to model the building itself. So if you have a specific use condition, probably you need to do some additional assessments to complete your scope.
So even cooling is then considered or not? Let's say
But
cooling
you have it's a good question. You have a possibility to add the energy consumption for those kind of things to your environmental impact. But infrastructure for the cooling, I know that it's specific. Some servers are cooled with water, some servers are cooled with, so that is not part of this modeling actually. Okay, we take the server equipments and we give you the possibility that we will show you in a couple of minutes to add energy. So if you add, for example, the energy consumption of the cooling and the general use of your building, I think you get a good impression of impact with that tool. But know that the infrastructure of building is not considered, and also the machinery that are used there.
Right.
Yeah.
We did some research about the to identify hotspots in entire data centers. I mean, this is going back. This is sort of research from about 6-7 years ago. But we found that even with all the M&E, the building infrastructure itself, etc., the IT, because of the refresh rate and limited lifespan, the IT was the hotspot anyway. So, and by that we mean servers, networking, etc. That element of the system had the highest impact. So buildings, the infrastructure is it's negligible.
Yeah, that's why I tell you, if you take the energy consumption for those activity plus your equipments, you get to a good proxy. probably you need to add something in the future, but you can already feel comfortable about something that you need to get from your impacts. Yeah.
Okay, thanks.
Any other questions? I think I was good. No? Okay, I was.
There is
Maybe.
one last actually
Yeah.
from Caroline. Is the cloud in the scope somehow?
No, unfortunately, cloud is not in the scope. But in my company, we recently did some counting for the cloud industry. We use the equipment, we look at the intensity of use of those equipments, and we do a modeling accordingly. Today, unfortunately, it's not part of what we provide in the tool. If you have information about your cloud provider, you can probably do some modeling using the tool, but yeah, it's more complex most of the time. So we have done some studies internally for companies who needed those kind of quantification, but I think it's too specific. It's not, we cannot more, for the moment, we cannot generalize that into a tool.
Okay, if there are no more questions, we're actually making really good time. We were going to have a break in between the LCA and the sort of application session, but we didn't. So I think now I make it 10:41. It's 11:41 in Europe. So let's have a break for, should we say 10 minutes? So 10:51, 10:52, 11:51, 11:52 will kick off, and we'll have a brief introduction to the CEDaCI campus for everyone, and then we'll go into the breakout sessions. So please, can you make sure that you have chosen your breakout session before we come back, so that Kate and Neil can sort out, your breakout rooms. Okay. Thank you very much, Naeem.
Thank you.
A comprehensive gallop.
Yeah. Thank you.
Thank you. So see you in about 10 minutes. Thank you.
Hey, nieuwe Bas. Hi. Hi. Ja, ik had jou nog geappt, maar volgens mij is het niet gezien.
So if you turn your mic on, I hope everybody's back from tea. Difficult to tell. Hello, France. Okay. Wait another minute or so, because we did have quite a long session. There are 21 people here. Do you know how many there were originally, Julie?
25.
Yeah.
Robert had to drop out for his kids. So, yeah. But because the recording will be available afterwards, he will be able to catch up.
Okay, well, I've lost you. That's it. Okay, so I'm going to start again, I think, so that we have plenty of time to interact with the tool. Okay, I'm a screen share. Okay, I hope everybody can see that clearly now. Okay, so The tool was developed, as I mentioned previously, as a key output from the project. It is free and online. The only thing that we ask is for you to register through the the CEDaCI network, because obviously we would like to know who is using the tool and so forth. But it's basically a product sustainability and circularity indicator that will allow you to compare environmental, social, and economic impacts and materials criticality in different servers. We are hoping to add some examples of networking equipment, switches and so forth as well. But I'm sure you can appreciate it's quite time consuming building the models, but we will continue to add data as and when we can. So once you have signed up, you will have, you'll be able to log in, develop a username and password, the usual bog standard stuff. And then you will see three options. The compare, which is really about product life extension, either upgrading or I guess as was described before, upcycling equipment. Then end of life is about various treatments, the CEDaCI recycling model compared with bog standard recycling or business as usual recycling models and landfill, and then the eco-design evaluator as well. So the compare tool allows you, and bear in mind that I think Naeem has really explained clearly how we use life cycle assessment and sustainability assessment to measure the impacts of everything from extraction of raw materials, manufacturing, assembly, transport, use and end of life. And we're using the circular footprint formula, which accounts for benefits and burdens, etc. So we're using, sort of proprietary methods and primary source data throughout. But what we've done is enabled you with compare to build your own data center. Now we don't mean it's really sort of focuses on a rack, although it could be a whole data center if you wish. But you can add information for 1 and 2 examples. You could add information, let's say, for an existing server without making any changes. And then the second data center or servers, you can make changes and then you can compare the impacts of both. So you can add various quantities of servers to your data center models if you wish. Here, you can see on the left, we've got 3 and 2 servers, and then on the right, 5, 3 and 4 servers. So slightly different. I mean, it really is up to you how you configure things as well. You have the opportunity to change various components, and you've got to have a CPU and RAM, but you can change processor, memory type, storage, fan, expansion, power supply, etc. And all of these are available via drop-down menu. Now, we haven't been able, obviously, to include every single example of a fan or a processor. That would be an infinite task, but there is a range of options for you. And then you can, and this was something that came up, was energy use and so forth. You can change your target load according to, according to time or duration of operation over a number of hours. And the geographical location is really important here, because obviously the energy mix in France is very different to that in, let's say, Italy. In France, you have a high input of nuclear energy and therefore low carbon emissions, but you do have the issue of what to do with nuclear waste at end of life. In Italy, there's a higher reliance on fossil fuels, but then different kind of problems, many more airborne rather than water and soil-borne emissions. So you can change these to suit your requirements. And then again, you'll see graphic results like this. We've disaggregated the results so you can see environmental impact is separated from economic impacts or life cycle costing, and the social impact and criticality impact. Now, some models will give you a single score, where environmental, economics and social impacts are aggregated, but we felt it was very important to separate those out so you can base your choices on your company's priority, be it economics or, if you've got very major concerns about social impact, you can base your choice on that. It's also valuable to see the difference between environmental impact and costing, etc. Now that the bars, the best way to explain this, the bars, so environmental impact, you might have a 50-50 split between one server and another, but the level of impact isn't necessarily exactly the same as the level of life cycle costing. It's very difficult to compare these three different, or four in this case, different sets of criteria. But what you can see is how for the different servers, the different criteria groups, if you like, how they actually relate to each other. So you shouldn't say that the social impact of the dark colored server data center 2, you couldn't say that is higher than the environmental impact for that data center or server. What you can do is compare the environmental impact or social impact of the two servers, but you can still base your choice on the criteria that you choose. You also get a printed copy of the results, which disaggregate the inputs, so you can see whether the impact of manufacture, for example, is higher than installation and disassembly or dismantling or data destruction. So you get more granular information in the PDF report. And the reports, this way of presenting data is the same for the various life cycle stages. Depends whether you want a sort of snapshot or, really detailed set of results. So the next element in the tool is end of life. So compare is really about product life extension. As I said, end of life is what happens when you finally realize that you need to retire your server. And there are a whole array of scenarios. If we concentrate on the right-hand side of the screen, scenario 2, and at the bottom, you can see there's end of life A, refurbishment, which is extension of product life for 1 year, and it includes transport and operational inputs, etc. End of life B is the business as usual, or as I described it, bog standard recycling. And in here, the materials that are reclaimed, plastics incidentally tend not to be reclaimed. In the main, they end up being incinerated as waste or dumped for various reasons. But so most of the materials that are reclaimed are metals, and typically they will be the low-hanging fruits, the larger components and things that are easy to recycle and reclaim. So that's anything ferrous, steel, etc. Copper, obviously with the in electrical components, there's a high percentage of copper, aluminium, and then usually gold and silver. The CEDaCI recycling scenario is rather different. As Naeem explained previously, we are reclaiming additional metals. So the recycling credits that you would get are higher. It's more beneficial. And then finally, we included end of life D, landfilling. Now, you shouldn't send things to landfill, but that we put that in to really benchmark or highlight the benefits of recycling or refurbishment. So again, you will be able to select various scenarios, 1 or 2, for example, and you will see the results of your choices. The data is, sorry, the data again is disaggregated. So if you look, you can compare the sustainability categories if you're looking on the left, the environmental impacts, the economic impacts, social impacts, and criticality are indicated by the different colours here. And then if we look at the results on the right, in this case, we are comparing the impacts of the various end-of-life scenarios, and they are highlighted. You can see environmental impact purple, how that compares, refurbishment compares with recycling using the CEDaCI scenario, the business as usual industry scenario, or landfilling. And again, you'll get a printed report if you so choose. And then the final part of the tool, the eco-design evaluator. This is where, and you know, initially I said that the product life extension and end of life were really dealing with problems that have been created by linear thinking and linear life cycle, or whereas the eco-design evaluator, that's much more proactive. And I guess if we start with initial circular designs, then many of the problems that we're having to deal with now will be reduced or possibly even eliminated. So in this case, the evaluator, again, it presents you with a whole series of options and drop downs here. The information is presented in a slightly different way. You can see on the right this spider diagram, and there are a whole array of categories here, 1, 2, 3, 4, 5, 6, 7, 8, 9 categories. The information in the categories is based on the criteria in the categories is based on the EU Circular Economy Action Plan, and also guidelines like Lot 9 and so forth. And we added in some additional circularity features. But the idea is that as you change the design parameters, you will see the infill in the diagram here will begin to change. You should be aiming for a completely blue filled web, let's say. So the lower or the less circular your design, the closer the results are to the middle of the diagram, and the more circular the design, then the results are shown at, sorry, the results are shown at the edge of the diagram. So we can see here, you might choose to have PSU with efficiency, 90%, etc., drop down menu. Any item that is highlighted or criterion that is highlighted as red is mandatory. But again, as you gradually begin to fill the diagram like this: red for warning, green for good, go, circular, solution. And that's also reflected in this bar at the bottom, which gives you an overall sort of snapshot view and overall score. This is a pretty circular survey here where we've got an overall score of 81%, but you can see where the obvious areas are for improvement here. In this case, it's design and manufacture, resource tracking and tracing, and then the power specifications there that could be changed. So just, oops, sorry, didn't want to do that. So you can see here we've got criteria changing. and criteria changing here. We've tried to make the interface as user-friendly and intuitive as possible. And that is the very brief introduction to the compass. So I'll stop sharing now. I think it's quite abstract at the moment, so we would really like you to have sort of interaction with the compass. We've got a reasonable amount of time. It's 10 past the hour now. So I think if we say, if we go to breakout rooms, we intended for you to go into one room for the whole session, or the whole part of this the session now. But it may be possible for, if you look at one aspect of the tool, possibly to, you know, join another room, but let's see how that goes. So you'll have a detailed introduction to either eco-design evaluator, the compare or recycling in your room. Okay, and there's a question here. What level of certification would the site need to facilitate the end-of-life scenarios? Naeem, I think this is sounds like a question for you.
Yes.
Oh, yes, here.
Yes. So, what level of certification would the site need to facilitate the end-of-life scenarios?
Yeah.
I don't understand exactly the question. What is meant by certification, actually? Would the site need to facilitate the end-of-life?
So, Manish, are you there?
So you mean what type of certificate you need in order to be able to explore the end of life? Yes. So
sorry, let me explain.
Yeah.
What I meant by the certification is Deborah's presentation. Thank you, Deborah, for your presentation, by the way. She mentioned within the end of life scenario. So there were 3 scenarios. All of them. She mentioned the end of life part. I just wanted to know what level of certification each site would need in order to split materials. For example, Deborah mentioned unable to recycle plastics, and they would have to go into, say, a proportion might go into landfill, for example.
Okay.
But all of these sites would need certification, right? You can't just you couldn't just open a server and start you know, taking components out. Obviously,
yes.
If you were to split a server, it's high-tech machinery that you would need, right?
Yeah. So if let me give an answer, you tell me if it's what you were expecting. So actually, if you have, and today when you have the servers at the end of life, normally you ask for a recycling certificate. So the operator will give you like a document that these equipments are recycled. In that case, your scenario is the business as usual scenario. It's the scenario that is presented in the tool as business as usual. If you have your normal recycling certificate, you can use that scenario. For CEDaCI scenario, if you participate this afternoon, we will explain more in detail how this process of recycling is working. Okay, and in that process of recycling, we are going far beyond. For example, we are going to recover some critical metals that are not recovered in the normal recycling processes. Okay, so if you want to go and use more, let's say, high recycling rates or scenarios, then you need to have further explore what is behind your certificate of recycling. How do they do it in reality? Or directly provide your equipment to another company who is able to recover those metals. I hope that that's more or less the answer.
Yes, like you said, if you're going into it in more detail in the breakout sessions, I could wait for that, Naeem.
Yes,
thank you.
You will see there, but for example, there they are using a new technology. So in that new technology, they are able to recover more metals, for example. In the today conventional technologies, for example, tantalum is not recovered. Tantalum goes with other metals and it goes to the scrap. Scoria of recycling, okay, because we recycle most of these equipments for the copper and not for other stuff. So it goes to a big smelter and we recover copper. All the others are going to scoria. So we cannot claim to have a good scenario in that case. Okay. Okay.
So shall we launch the breakout rooms now? Okay, Razi, this is the feature that you have.
Yeah, and I'm adding that it's possible for everyone to join whatever the groups that they want. It's not mandatory for you to select. We have 2 rooms and you can select in between. I will open all the rooms.
Thanks. So below on your screen, you have you should be able to see the join a breakout room, and then you can join by yourself. And I will stay here if there are any questions.
And so Julie, Neil told me that Dominica is joining our recycling session to run the video from.
Yes, I'm here.
Okay.
I have the video. However, I don't see the option to join anything. So
If you go down your Zoom, you have like 4.
Okay, I see it now. Thank you.
Okay.
Okay, let's go there. See you then. See you, Julie.
Thanks, Naeem. Which other rooms? So Katie's refurbishment. Okay, she joined.
I think I still have troubles to join. I can see the rooms, but I can't see any join button.
So I will add you to which of the groups I should add you?
Recycling.
Recite.
Thank you.
You're welcome.
Thanks. Well, if you can hear us, we are now choosing the rooms. So you can select the room yourself.
So
because how do we do? Do you know if someone has to stay here?
Paul selected the recycling, so I will add him to a recycling group.
Okay.
So there are 8 on the life extension, 4 on the eco design, and 6 on the recycling.
So we have to stay here, or what's the?
I guess we can stay here because they might, for example, Paul is not yet joined. I added him to the group, but we can stay over here if they want to come back or have any questions.
Yeah. And the breakout rooms won't be recorded.
That's not possible, I guess.
Mm.
Maybe I can go and join one of the rooms and give it a try, but at least one would be recorded and the rest it's not possible.
Yeah, because last time, which one did you join?
I guess we had no breakout rooms. It was just happened during the meeting, and I can give it a try and join the, for example, eco design room, and let's see what's happening. I guess it's recording the main screen. So let me join the eco design. See you then.
Later. And this is who's recording?
It's me joining to make sure the recording is happening. But the feature is
that's fine. That's fine. So we did use the tool to support development of a CEDaCI circular server, which you can see here. We are applying for intellectual property, so can't show you anything in detail, but at least you know that the tool has been genuinely tried and tested. So I mentioned previously that the criteria came from Lot 9, etc. Also the EU Circular Economy Action Plan. And it's interesting, this was published in 2020, but we're already beginning to see some of the criteria in the action plan are being developed into beyond guidelines and more into regulation. So things like right to repair, etc. We always knew that or felt that the criteria would become mandatory. So we were a bit ahead of the game here. So if you use the tool, you'll definitely have an advantage over competitors. So Chris developed a really good methodology for this. The input is all based on Excel, but we identified 10 key areas: PSU efficiency, power factor requirements, etc., security, software and firmware. Firmware is really important, obviously, because at the moment it tends to expire after 8 years. So even if you wanted to change things or maintain servers, etc., it's very difficult to do that. So we believe that firmware should be open access or open source. Product specific information related to market entry point and after sale, availability of instruction manuals, guide for product, that would include a guide for upgrades and also product disassembly, making sure that the design is easy to disassemble, and we can talk about that in more detail in a bit. Design and manufacture, the chemical content and recycling, resource tracking and tracing, and then finally circular economic and environmental considerations. So the data was all put into a spreadsheet, and then the criteria were grouped and were awarded scores from 0 to 4. So you can see, it took a long time to sort of work out the various criteria and to allocate weighting where appropriate as well. But basically you can see that there's a point-based system, and there are bands, red being very low circularity, 0 to 39%, and then very good circular design is 90 to 100% with a score of 4. So we can see that the power efficiency, power factors, PSU efficiency, etc., that came from lot 9, and this is mandatory field that you have to add here. We've already said that red indicates mandatory inputs. So going through, we have here power specifications. These are the criteria groups, security, firmware and software. And if you look at the criteria as well, are there open source options for upgrades, updates and upgrades? That isn't mandatory in the tool. Although I guess, Chris, we ought to look at this because of the changes that are being introduced, the design changes that the EU are reducing. I think we need to double check whether there are any needs to change the criteria here. Availability of product specific information. So that could relate to recycling or OEM, etc., ASHRAE glass, data sanitization, instruction manuals. It's quite surprising how many products don't include those. It's a bit scary, particularly for things like disassembly, although this is changing because of the right to repair. And then product disassembly, how many of the products or different components can be disassembled. That tends to, at the moment, to relate to the big components, just taking the casing apart and so forth. Many of the internal components are not designed for disassembly. So they, particularly things like plastic components, they may have one-way clips. So when you try to separate them, they break, or they are, welded, heat, or in some sort of heat joining method with metals and plastics. There are also issues around the materials. The plastics are, one thing we should have mentioned but didn't, is that they are heat treated for, fire safety, but that means that you can't recycle them. So it's a big issue. Design and manufacture, I think most of the products or components in the service or networking equipment, they could be designed to be easily disassembled and recycled, apart from the actual electronics, the key bits, the motherboard, etc. And this is if we could sort out a way to disassemble and separate materials in tiny electronic components, then that is the holy grail of end-of-life treatment. Chemical content and recycling, everything should be RoHS compliant, should be, yeah, we hope. But we find that there is very rarely any information about the critical raw materials content, and bearing in mind some of the challenges that we're beginning to face now, I think that will become mandatory. We certainly need to be mindful of critical raw materials. Resource tracking and tracing, again, that is something really important. It'll become increasingly important, and there are lots of I know research projects linked to this as a process. We're trying to identify best means of doing this. Circular and environmental considerations at the moment, product refresh rate, maybe 5 years. Someone mentioned cloud, and obviously that's linked to hyperscalers, and we know that their refresh rate is nowhere near 5 years. There are rumours about it being as brief as 9 months, but it's generally, I think, about a year. But obviously, refresh rate has a significant impact on overall life cycle impact. So if this is a sample study comparing a G10 or generation 10, generation 13 servers with CEDaCI circular server. So you can see that the G10 and G13 didn't do very well in terms of design for circularity. They're in the red zone, whereas the CEDaCI circular server came out more favorably. It's not brilliant because it's still only in zone 3, the light green zone, 75 to 89% fit for circularity. And those are the results there. This is an old diagram, actually. We've changed the graphics, although the content of the diagram is the same, but you can just pick out the blue server, which is the CEDaCI server, and how that compares with the red and green, the G10 and G13 servers. And you can see, for example, red G13, security is an issue, as is software and firmware. Now, they're not things that are difficult to sort out. The manufacture of electronic components is a lot more challenging than changing rules about firmware and open source. So there are things that could be done comparatively easily. Oop. And then I showed this slide before. This is the revised graphics with the CEDaCI circular server. And as we said, you've got the snapshot at the bottom, which again, this all changes in real time as you're changing criteria. And this is our beautiful circular server that Chris has developed with the CEDaCI on top. And the key things here, we mentioned at the beginning, reversing or dematerializing, increasing resource efficiency, sort of reversing this idea of more materials, it means that something's automatically better. We're not compromising physical performance. I think that's a key thing to mention when we're talking about dematerialization. So the standard server is around 22 kilos. The CEDaCI server is 14, so that's a considerable reduction in mass. And it's interesting, if we jump down to the mass of plastics at the bottom, and again, one reason why a lot of plastic components have been eliminated is because of this inability to recycle. The plastics in a normal server are almost 900 grams. In the CEDaCI server, it's about 86 grams, so a huge reduction. And again, that's to do with the way in which the server, the fittings and so forth, for example, have been designed. Chris will be able to talk to you about this in more detail if you wish to know more. And the number of components, the number of components has also been rationalized. So on average, a standard server may have 116, but in the CEDaCI server, there are only 65 key components. So that's the sort of overview. Has anybody got any questions? Everybody's happy. Okay.
No, not exactly. I have a question. Maybe it's not the right moment, but the primary resources, so the raw resources, is there a criteria which measures that the raw resources can be captured?
In the design part of the tool, or
yeah, in the eco design part, because in my view, it's really difficult to get the raw materials out to reuse it again.
Ah, so, that you mean? So you mean at end of life, extracting the raw materials for?
Yeah, for use of urban mining, yes.
Oh, urban mining. Okay.
Yeah.
I mean, we haven't considered that. We've considered again, you know, the scope of our time frame, etc. It's really difficult. So we've just considered sending things to the business as usual recycler and the CEDaCI recycler.
Yeah.
I guess you could say, you know, landfill is, well, there's potential to urban mine there, but that's not, we haven't built a model around that, but it's something to consider, definitely. Yeah.
Yes, because now it's the level of be able to get some functionality out, and we replace it and repair it. But this is another level. It's yeah.
Well, I guess the only problem with urban mining would be that you'd have to test all the materials for their composition, you know, especially their alloys, test whether they're still working, you know, if you're electronic components. So yeah, it would be, it's complex. I mean, personally, I think that if we start urban mining, I think it's most likely that whatever is taken out of landfill will simply be sent to a recycler and processed rather than being reused at the moment. I think that's the most economic option at the moment.
Yeah.
Because it is a policy issue.
Yeah. Oh, okay. Yeah. So
and in theory, because servers are subject to you know, EU law, etc., they shouldn't be just dumped and sent to landfill. But I mean, some parts do end up in landfill, but it'll be the low value stuff. Yeah.
Because we really have to get to urban mining. We really have to. Yeah. Otherwise, it's not circular.
Yeah. Yeah, but you can, if, okay, that's an addition to, I suppose I see that as part of the, you know, the recycling element within the waste time.
Okay.
Yeah.
Okay. Yeah. Okay.
Okay. Any more questions?
Yeah, I have a few. My first question would be, in designing this server, what were now the components that are still not recyclable? So what's really making that this server is not 100% recyclable? What was the most difficult, let's say, component or material to exclude, making this server work?
PCBs and plastics.
PCBs and plastics. All right. Yeah.
Okay.
So okay. So the 85 grams of plastic, that's just not. There's no alternative, let's say, for the function it has to do, to make it out of any different material.
Well, yes. I mean, you could do, but I think that was quite difficult, just because it's quite a small part. we didn't consider airflow because usually servers have a buffer that makes airflow. So we didn't include that in the design. We just left it for the future designers, that manufacturers, to iterate in that.
Right.
That could add to the plastic composition, but that material can be used from recycled sources. It doesn't have to be fire retardant to the extent that, you know, most of the, I don't think it gets hot like to that extent to actually set something on fire.
Yeah.
Major problem is electronics design, because everything is just fused, and that includes hard drives or you know, SSDs or HDDs and you know, chips. It's just everything is glued together. So we tried to modularize a little bit. We separated some parts of from the motherboard into a separate PCB. So if, say, a component blows in particular, say we did the air cooling. So if the component blows for a fan, it's a separate board. It can be replaced rather than the whole. At the moment, fans are integrating the whole motherboard, so that sort of stops the excessive use of material. And interestingly enough, we've disassembled 18 different server models and generations, and a lot of design ideas were taken from previous generations, much older. Some of the first generations, they actually had very good concepts and ideas. Some of the servers had separate PCBs for different functions, and then gradually they integrated everything into say motherboard.
Okay, good. Thanks for that information. Another question was, let's say the metals. What kind of finishing do they have, and how does the, let's say, the finishing of the metal to make it anti-corrosion, how does that impact its recyclability?
I think it was standard galvanized steel, as far as I remember, but I would not be able to give you the full composition. I think Naeem probably will be the better person to answer those questions in terms of the chemical composition.
Yeah. Okay.
I'm slightly conscious of time here because it's 37. Sorry, sound really anal. It's 37 minutes past the hour, but we'd like you to have a play with the tool. I mean, we can answer more questions after, but yeah, please log on and have a go, and then please keep asking questions, because it's great for us, because we're learning from used participants where maybe they're like the urban mining, Caroline. I think that's a really interesting point and something we need to think about. So yeah.
Just if you use the link we provided in chat, that should work. And I was advised that people should not use their email address as their username. It should be your username when you log in. Have you managed to log in, everybody?
Yep.
If you go to evaluator section straight in, and then you can shoot your questions. I'll be happy to answer.
In the meantime, I have also another question. Have these, let's say, the lessons learned from this exercise, have these been shared, or is the plan to share these with, you know, the big IT companies, vendors like Dell, HP?
We because some of the features there may be IP related to them. We're being a bit, obviously, you've got to get that sorted out. What we don't want, well, I think we're going to try and make this open source if possible. Yeah, maybe through Open Compute, or because what we don't want is for a big vendor to take it and shelf it. You know, we really want it to be in the public domain. But it's yeah, I mean, they will be able to use this tool anyway and design their perfect circular server. But what, Chris? Sorry, Chris, did you say something? No.
Someone else, I think.
Yeah, but everybody will be able to use the tool. But we hope to actually make a prototype. I mean, that's another reason why we are investigating IP at the moment, but it's a slow process. Yeah.
Right.
Okay. Okay.
The other thing, this is probably teach my grandmother to suck eggs, so I'll just quickly screen share. If you make sure that you click all the criteria, if there's a bar at the side, then you have to scroll down. Some of the boxes have, you know, only a couple of questions, but some of them have a lot of questions. So please make sure that you answer them all. Razi,
Yeah.
how long, when do we want to join the other group? In 5 minutes, 10 to, do you think?
That's possible.
How are they doing?
Want me to check the other groups?
Yeah. Yeah. So we can get some feedback and what have you. And I have to go bang on 12 because I've got an exam board.
Yeah.
Sorry about that. Okay.
We have almost less than 15 minutes. Am I right?
I make it 46. So yeah.
And also you can highlight that you are part of the project. We are back, I think. We are back to the main room.
Hello, everyone.
Hello.
Are we done here with the presentation? Shall we go back to the main room?
Yes, let's go back. Yeah.
Yeah, great. Everyone, I guess you have the opportunity. You can select to go back to the main rooms.
Okay, but Bram, you wanted to ask a question because you activated your video, no? Was there any question from you? Everything's good?
Exactly, just showing up and nodding.
Okay.
This was a very interesting session and presentation where I didn't have questions to contribute, but just
you're welcome. Thank you.
Show my activity.
Perfect. So Razi, how we can go back?
So if not possible, I will check with the other room and then close all the rooms. Then we'll.
I think you need to close all the rooms and then everybody goes together.
Yeah.
That's the only solution.
Yeah. I will check the one more room and then close the rooms.
Yeah. And I think we can already click on the close the room on the.
Within the EU and now extending it also global and using this. But then having the same language, that is very important, I think.
Okay.
Hello,
Razi, have you come in to tell us to leave?
Yeah, that's the point. Let's go.
Okay. We'll see you in the main room. Do we have to click on anything to get back in
Leave
there?
at the right corner.
Yeah.
Okay.
Thank you.
Okay.
Thank you, Astrid.
Thank you.
Now
I'm in France.
France, okay. So you have seen the crazy weather in previous days, no?
Yes, 39 in Paris this weekend.
No.
I'll take the train tomorrow to London.
Yeah.
I think we are missing one room.
They're coming now. They are. Yeah.
Perfect.
So I think everybody's back, Deborah.
Thanks, Dominique. Yeah, we will send all the presentation recording. Thanks for joining for this session. We'll be in touch. Have a great day.
Oh, hang on, Julie.
No. I was responding to Dominique because he left.
Okay, sorry.
Yeah, no worries.
Okay. I think Neil, is Neil there?
No, Deborah, Neil's not on this one. It's Kate.
Oh, hi, Kate. Sorry. Have you got, do you want to share a questionnaire or a feedback?
I'm afraid we can't share it today, but I thought that we could use this part to ask for feedback, and also we could communicate about feedback via email.
Yeah. So we really appreciate your feedback. One of the things that has sort of helped us to improve the accessibility of the tool itself, that, from a UX design perspective, and also content and features, has been feedback from you as industry experts and users. So we really appreciate some feedback. And as Kate said, that she will send the an email, a sort of quick questionnaire would be really, really helpful. We've got just under 10 minutes. Has anybody got any questions or queries that they want to, anything to ask before we...
Or even any feedback, positive or negative on the tool, yeah.
Any feedback?
No, not right now. I will look into it.
Yeah, but please, if you join the, as you did, Caroline, the Eco Design Evaluator, then please have a look at the compare and the recycling elements as well.
Yes, of course.
We will be having more training sessions. We haven't decided on dates yet, but we will be having some more training sessions. So if you say, for example, if you joined Eco Evaluator today, then you could join Recycling Group. If you wanted the more formal, detailed discussion, then, you know, we're more than happy for you to join another session, and you could either join or skip the preliminary LCSA input. It's up to you. But all of the info for CEDaCI is on the website, which we'll share, and so you can join the network via the CEDaCI website here. We're not very good at, well, we do put some stuff on LinkedIn, not so much on Twitter. We tend to leave Twitter if we're use Twitter if we're at events. But all the news, any publications, etc., news about further events, live performances or appearances, all of that is on the website as well. Okay, so please have a look at those. So if everybody is happy, or if you're shy and you don't want to voice your feedback, that's fine.
I do have a question.
Yeah, good.
About, so there's now a limited set of electronics that you can select in the CEDaCI campus as you're configuring a system. And is there, what's the expectation on additional example materials to select there?
You mean when we keep adding to the data set?
Yes, exactly. So computers, components.
We will. I mean, we've got some more stuff that has just been sent to France for recycling, for example, again, to ensure that we've got primary source data, but we've got a shopping list of servers, things that we would really like to add to the data set, and we can send those out. I don't know, what does your company do, Bram?
We're interested to also build IT tools for selecting sustainable IT. And this is it's a great platform to build examples. And right now, when I try to make a comparison between two systems, I can't really differentiate those systems because I don't have enough options, I think, to really demonstrate what the tool is capable of. So I was hoping, if you happen to know that if there's a timeline for, there will be additional data in a month's time, or this will be down the line, because it takes time to study these things.
So we are doing some massive characterization at this moment. And I hope that we can put those numbers into the tool at September, for example, somewhere in that time zone.
The idea as well is that, well, we've still, Chris mentioned we've disassembled 18 servers, but we'd still like to disassemble more. We've got some in the pipeline. We keep, begging people for equipment because, as you can imagine, it's got high economic value. So, yeah, we have to rely on the generosity of other suppliers to get the servers to disassemble them. But we intend to maintain the tool after the project finishes in July, August 2023. We will maintain the tool, and as and when we get new servers, we will add, and we also want to add some network equipment as well, some switches and so forth. But we chose servers because they have the highest environmental impact, mainly because of the motherboards and so forth. They really the sort of small electronic components. They have the highest environmental impact. Okay.
Thanks.
But as Deborah said, everything is built in a way that we can add any components that we wish to the system. It's quite flexible, but it's too much work. Each time adding a new equipment, we need to do a lot of steps, and we want to be precise. So that's why, yeah, it takes some time.
Yeah. Okay. Any other questions?
Yeah, a question. So today was all about, let's say, servers. Of course, a very important component in data centers. But as, let's say, an infrastructure manufacturer, I would also be interested to see how we can, let's say, adapt maybe this methodology that was shown today. How we can, let's say, use that or apply it to IT infrastructure. So whether it's cabinets or cooling or UPSs, PDUs, all those components. That I mean, I think the methodology can be fairly the same. It's just the different type of products.
Yeah.
And I'm not sure if let's say SDIA has let's say similar groups which are less focused maybe on the IT equipment itself, but more on the infrastructure. But yeah, that's just a comment. I think the work that was put into this was very elaborate and looked really professional. So I definitely learned something here. Yeah, as a next step, I would be really interested to see, okay, how can we apply this methodology to other products? Yeah,
I think that there's infinite scope for this. Perhaps it's something we could talk about later on, and perhaps do collaborative work on this. I mean, yeah, there's still lots of funding available for projects like this. So we have your details first, so we can get back to you on that one and certainly talk about it. Definitely. Okay.
Good. And why not define even other projects in the future? I think there's an opportunity to extend with other projects. Yeah.
Yeah, exactly. Well, I'm going to have to go, I'm afraid. I've got the joys of an end of year exam board in 2 minutes, so I need to run. But
thank you so much. Thank you. And yeah, thank you, Julie, for organizing.
Thank you as well. Yeah.
Thank you. Thank you, everyone. Bas, you still have your hands.
Oh, sorry. No, yeah, that was the same question.
Bye. Bye. Bye.
Have a good time.
Bye.
Bye.
Ciao.